Okay, hello everyone. Welcome to week 8, day 2. So in this session, we're going to look at set operators, variables. I'm going to push ahead the user-defined functions. I'm still working on those materials. So we're going to cover set operators and variables today. Let's get started. So this is the files we received in the email. Let's begin with variables. I'm just going to open the SQL variables file we have. So this is week 8, day 2, SQL variables. So a variable is basically an object that holds data. So I saw this on online. I just thought it nice to share. Think of a variable as a box that acts as a placeholder for whatever value you want to put in it. Right. So it's basically an object that holds data. So we're going to talk about how to define a variable, how to set the value it will hold. Right. It's basically an object that holds data. So you're going to insert a value and the variable will hold that value for you. Whenever you need the value, you can just call it, right? So it's an object that holds data, holds information. So a variable is an object that holds a single value of a specific type. So usually when you're defining a variable, you use a declare. You set the name of the variable. I think we've seen this previously in stored procedure, right? In this case, we're calling it variable. In stored procedure, it's called a parameter, right? So this right here is the symbol for the variable, right? If you exclude this, the system will not understand what you're doing. So that's this symbol right here initiates the variable or parameter object type. And this right here is a type of data the variable will hold. So a variable is an object that holds data. And of course, it holds data of a specific type. This is very important. So each time you define a variable using the keyword declare, you must define the type of data that variable will hold. This is very important, right? So we typically use variables. I just talked about this in a stored procedure or a user-defined function. We're going to see that we've seen stored procedures, and we use variables in stored procedures as a parameter, right? So when you pass a value into the parameter, it will change the behavior of the stored procedure, right? We're also going to see variables again in user-defined functions. Right. And also in this example, we're going to see scenarios where you can define, you can investigate the value, and then you set it to a variable. And then when you need it, you can just call the variable. Similar thing we did in a subquery. So all those examples we solve using a subquery, I'm going to go over them again using this technique right here. We're going to define the value, for example, the list of products with weight above average weight. You can actually investigate the average weight and store it as a variable. Assign the value to a variable, and then now you do your select statement where weight are greater than that variable you define, because the variable is holding the average weight. So we're going to explore this technique. So this technique is popularly used. This is also used for stored procedures and functions. So in stored procedures, we call this a parameter. It's still it's a variable actually. Same symbol we used. See? So defining this is easy. I saw this article online right here. Let me share this. That same article, you're going to see the link in the research portion of the week 8 objectives. You're going to see right here. The links are there just for further research. Right. So pretty much at week 8, you can basically investigate any SQL topic on your own. You just read and understand. You have a solid foundation on SQL already. So this is what I was discussing now. Declaring a variable. To declare a variable, you use the keyword declare. So this is the declare statement. For example, the following statement declares a variable name. So of course, every variable must have a name, and the name must begin with this symbol, right? And every variable defines a specific data type or holds a specific data type. So this is us declaring a variable we want to create called model year, which will hold data of type small int. Small int is just a smaller version of the integer. The storage capacity is limited, right? So this is an example right here. Let's go ahead and declare a variable called model year. We'll set the data type to integer. And then this is us providing the value of model year. If you do not provide a value, by default it will be null. So we are setting that model year should hold this value 2025. Now this is us calling the model year variable. And the good things that all of this has to be executed together. There's always a temptation to run these things, it gets submitted, and then you run the next one, you think it will recall, you see. So you must declare all of them together. See, you cannot run this and you think it's going to process and store the information, then you can run this. You see, it fails because all needs to be executed together. That's one thing you need to remember about variables. The declaration of the variable, setting the value to the variable, and then calling the variable. All these three steps need to be executed together, right? And then there's one part using the variable now in problem solving. This is all just declaring and then calling the variable. Right, but in the next steps, we're going to see how to declare the variable, set a value to the variable, and then call that variable in some other process to generate other results, like right here, to hold a value to be tested / returned in a subsequent step, right? So these are three steps that you have to remember. You declare a variable. The name of the variable should have this symbol, right? And each variable stores data of a particular type. If you ignore any of this information, you get an error. And then this is us setting a value. You can now define what value would this variable hold. So it's like saying x equal to 2025. Then when you say what is x, it returns 2025. So this is the issue right here. What is our variable holding? That's when this thing will run and generate. But you cannot just highlight this one and execute. So the declaration and the setting of the variable has to be done together, same script. So why is this returning 2025? This is the last line to be executed. Return the content of the variable. That's why we're getting 2025, because the variable was set to what, 2025. If I update this to 2026, the variable will run and return this, you see. So this is very important. Let me just do another example. This popular one where you can set x equal to y. I will use this x equal to maybe 1745, right? And then what is x? If you call x, it should return 1745, right? So in SQL, you can actually do this through what we call a declaration process. We declare x, and then you don't just type x, you put this symbol in front so that the system understands as a variable x, right? That's the declaration of x. X is going to hold an integer, for example. Now you can go to the next line and you set the value of x. I can also stay on this line and put equal to. Right, anyway, I'll come back to that one. This is it right here. So this is you declaring and setting the value all in one line. So I'm skipping the keyword set. Right. So let me do this for x equal that. I'll just do the two steps. X equal that. And then I'm setting the value for x. The variable x will hold the value 745. Now if I call x, select the variable x, if I execute all of this, the final thing to be processed will be this one. This is just declaring the variable. This is setting the value, and then this is calling the content. That's why we have this. See? Now approach, let me do a second version with y. I have a variable y equal, let's say 1540. This time around, let me use okay, let me just use the number 1540. I can then proceed to do this in a single step. I want to use the declaration of the variable and setting of the variable all in one line. So I declare the variable, always remember the symbol in front of the name of the variable, equal to, no, I have to put the data type. And then you see I'm skipping the set part. You see this part right here. I want to skip it and just go directly to equality, and then I set the value. So yeah, this is allowed. So you can dismiss this set and then just put this directly equal to the end of the declaration statement. So you're fusing the set. That set is used to assign a value to the variable. This is defining the variable. This is assigning a value to the variable. So these two can be fused together and it's going to look like this. Now we are just left with calling the variable or printing out the variable. Some people use print. If you do print the variable, right, see what we get. You have to execute all of that. So printing a variable, the print concept doesn't show up as a table. But then if you do a select, it's built to return a tabular construct, tabular outcome where you see the columns and the rows. So if I do select, wow, you see the value shows up within a tabular construct, one column, one value. See, right. And if I now want to perform some kind of calculation by saying, hey, give me x plus y, give me the value the variable x is currently holding plus the value the variable y is currently holding. Right, you see that? I cannot just run this alone. The system doesn't know what x and y is. And when you declare a variable, it does not get stored in the server, on the server. That's why you have to keep running this. You see, it looks like the system runs it and forgets about it. It doesn't recall. So when you need it, you need to embed it in your script and execute it. When you click declare this execute, it looks like that's run and stored it somewhere. No, it doesn't get stored anywhere. Right. And then next, if you go now to this and say, okay, I'm going to set that value of declared, that variable I've declared to this. It says, oops, you have to declare the variable, but I just declared it right here. Now you have to declare it all together in one. You see that? And if you go below and do this one, same. And then now when you get to this part where you're calling the two variables, you're summing them up, the system tells you, I don't know what you're doing. You must declare them. So at any execution, you must declare the variables, right? So if you want this particular one to run, you have to bundle all of this. The declaration of x, setting the value for x, declaration of y, setting the value for y, and then now doing x plus y. All right, you see? And this is what we get. If you don't want to get the in-betweens, you can suppress this one where it prints out x. You can also suppress where it prints out y. This one. And now you just run x plus y. So you're going to get one select, one print out, which is the sum of the x and the y. Right. Let me just go back. So these are some of the things we want to do. This can help your query looks more nicely presentable. Let's take another example. So the same thing, I've worked mostly on integers. We can do the same for a string. That's a text. You're storing words, text, strings. You declare a variable called my school. This variable is meant to be a string varchar. 20 simply means if you count the number of words, it should not be more than 20. So there's a maximum number of strings or characters this variable can support, right? So now if I call that, I get this. See that? And this is that example where we combine the declare and the set all in one line. So you can declare a variable and then you just put equality, you set the value without using the set keyword. You see the set keyword? Now you can just call the city variable and that's what you get. So a variable is just that object which holds data. It holds a value, right? When you need that value, you can just call the variable and it will show up with the value, right? I want us to go back and visit an example we solved using stored procedures. We're going to solve that same example using variables. So I think we've covered this part. This is a very important article. Create time and use it. So by default, when a variable is declared, its value is set to null. If you actually want to set the variable to a given value, then you have to put the keyword set and then you declare like this. See? Now using the variable in a query. So you can define a variable and then use it in a query. That's the part we want to address now. You can recall this example. We solved this example using a subquery. We wanted to know how many salespeople have year-to-date sales greater than the average sales person year-to-date, the average year-to-date sales basically. So how many persons year-to-date sales are greater than the average year-to-date sales? So this is an unknown we have to investigate. See, average salesperson year-to-date sales is basically the average on this. So that's a part that we need to investigate. See that? Let me first of all switch a database to this. Right, so we don't know the average year-to-date sales. We have to investigate this average. Right, and this is the investigation we're doing right here. See, we are investigating the average year-to-date sales. Right, so where I'm heading to this is instead of just assigning an arbitrary value to a variable, you can actually run a select statement to fetch a value and then assign it to the variable. Right, so for example, we've computed average sales right here. We can set this average sales, this value, to a variable. It holds this value. When we need this value, we just call the variable. That's what we're going to do. So I want to begin by recalling what we did for a subquery. So this is a subquery approach. The inner query will investigate the average year-to-date sales. This is the answer right here. And then it will then pass that value to the parent query. This is average year-to-date sales. Now this is the parent query counting the number of salesperson whose sales year-to-date is greater than the average. And so upon execution, this is the result we get. There are 8 salesperson whose sales whose sales year-to-date value is greater than the average. There are 8 of them. See? If you want to see the full list, you can just put an asterisk right here, and this will print out the list. See, but since we're asked to count, if you go back to the question, how many? This is a counting process. That's why we're using the count on the business entity ID. Right. So this is option 1, subquery approach. Right. We can do the same option 2. Let's use a variable. So let's declare a variable which will hold the average sales year to date. You see the title of this variable, and this, of course, must be present. It shows as a variable. And then every variable must have a name, and the name must carry this symbol, and it must also have a data type. Average sales year to date, that's money, that's financial data. Now this is us setting the value of the variable we just defined to a query which investigates the average year-to-date sales. See, remember this query, this right here, is the same as just copying this value and then you dismiss this and set that variable equal to that. Of course, this is static. It defeats the purpose. Right? We want our variable to be dynamic. It should be able to compute that value and return it. This is pretty much what we've been doing above, just hard code a certain value. But I want to show you a dynamic way of fetching the value using a query. So this is how you do that. You fetch the value which you want to assign to the variable by using a query which will execute and generate the value. So this is not hard coding, this is dynamic, because each time this query will run, generate the current average year-to-date sales, and then pass it to this variable, and the variable will hold that value until you need it. You can call it. You see that? So this is a much more efficient way of assigning the value of a variable by pulling it from a SQL query. Right, and that's what this part is addressing. There's a part right here, storing query result in a variable. Yeah, this part right here. So first we declare a product variable, product count variable integer. Then you set the product count to be what? The query is placed in a set of parentheses. That's the count. See, the open and the close. And then you can now use it further in another query. So the same thing we're doing right here, we are using this query to investigate or compute the average year-to-date sales. That's a value we're missing from the equation. All right, then we'll take that answer and assign it to a variable we've defined. See, so this is a variable we've defined, average sales year-to-date. We are now setting the value of that variable to this query. This query runs and generates this value. So pretty much it's just taking this value and doing it, this assignment. But this is hard coding. We want to make this process dynamic. So let's put the query behind that value. And now see, we can use it in that investigation. Remember, we did the count of business entity ID for those salesperson whose year-to-date sales is greater than that. And that's the same query right here. Same thing right here. But then since we know the average year-to-date sales has been stored in a variable called this, then we can just put where that is greater than this. Right? The system will then print out this value, right, and simply put it right here. A variable holds a value. When that variable shows up in any spot, it prints out that value and attaches it to it. So this is what you get. The value, the variable will expose this value, and that's how you'll be able to run this query. See? Now let me back up. All right, so we are putting this variable right here, which is holding that value. So if I execute everything, this you have to remember, for variables you have to execute the full script, including the declaration, the setting of the value, and then using it. Of course, if I just run this part, it will not understand what is this, because I've not included the definition in the execution. So you see, you get an error. You must tell the system what this is. That's a variable you've declared. It will hold data, money, and this is how we set the value the variable will hold. It is holding the average year-to-date sales. And now I can call it in this to filter. So if I execute this, this is what you get. This same thing right here, we used it in stored procedures. So under normal circumstances, I was supposed to cover variables before stored procedures, because variables are predominantly used in stored procedures and again in user-defined function. So this is similar to what we did in stored procedures. Now for stored procedures, you don't put the keyword declare, you just create procedure, you put this, the name of the procedure, sorry, you put this, and then you put the data type, right? And then you just go to the where clause of the stored procedure and use it. See? So this is it right here, option 2. See that the answer to option 2 and the answer using option 1 are the same. We are counting the number of salespersons whose sales year-to-date value is greater than the average sales year-to-date value. So now it all depends on you which one you want to use. Always remember that a variable is simply an object which stores information. Information stored is simply a value. You could just impose a value arbitrary, like what we are doing right here. But this is practically, this is not what you do. The value will be pulled from some query. See, like what we have right here. This is typically what will be done in a company. Right. So a query will run and generate the value which you assign to the variable. I want you to see this difference. Here, we're just making up a value and just, assign it to the variable. So this is not being pulled from anywhere. It's just this is assigned to this. Right. And when I call this, I get the assignment value, the assigned value. All right. But typically, a query will be used to investigate the value of the variable. So again, of course you have to set the variable, provide the data type, declare the variable, provide the data type, then set the variable to the outcome of this investigation. That's the value right there. So this is a value that is assigned to this variable. And when I use that variable in another statement, this is what we get. See, so this highlights the point we made right here. So we typically use variables in the following cases: to hold a value to be tested / return in a subsequent step. So this is us defining the average year-to-date sales, assigning a value to the average year-to-date sales is going to hold this value. Now this is us calling it in a subsequent step when we need it. In this step, we want to look at this salespersons whose sales year-to-date value is greater than the average sales year-to-date. And what's that average is a value that is held in this variable and is pulled from this query. Right. Okay, I want to stop right here for questions before we extend. So we have two options right here. We have the variable option and we have the subquery option. Any question before we proceed? Okay, so I think Tunde, you're just joining. We are looking at variables. So a variable is simply an object that holds information. So usually you define the object using the keyword declare. So I want to assign the value 745 to the variable x. So x is a variable. So this is how you do it in SQL. You define, you declare the variable, and always it begins with a symbol. This is the name of the variable. This must be present, and each variable should be defined with a particular data type. Right. And then we use a set operator to assign a value to the variable. Remember, we want to put x equal to this. So this is the variable x will be assigned to this value. And now this is us calling x. If you call x, the variable x, you get this value. And all of these steps have to be executed together. Right. You cannot do this followed by this and then now followed by this. You start getting an error. At any moment you must declare the variable. So this is, now you see we get 745 because x was assigned to the value 745. Right. Same thing for y. You want to assign y to the value 1540. In this step, I kind of fuse the first and the second lines together. So you can do that. You can dismiss the set and then you simply push this directly to the same line as the declare. So it's the same interpretation. We are declaring a variable called y, which holds integer, and we are setting y to this value. Right. And now we can now proceed to say, hey, can you print out y? Let me activate the select. So this is it. So this is just 2 lines compared to this one, which is 3 lines. Right. So since we've declared x and y, we can now add the two together. But you cannot just run this line. You cannot run x separate, and then you run y separate, and then you get ready now to run the combination. It doesn't work like that. Right. So they all must be executed together. Where you define the x, you define the y. Alright, so I'm just going to deactivate this and deactivate this as well, so that the system will just give me the addition of x and y, x plus y. What is x? This is x. What is y? This is y. So it is basically this plus this, and this what this is calculating. I have to submit all of them. So each time you are using variable, the declaration of the variable needs to be executed. Right. And this is another example. I want to declare a variable called model year, which is going to be an integer. I set model year to this value, and then I then call the variable model year. I should get 2025. So all of this has to be executed together. See? Right. And the next one we talked about is this example. This is now the practical application. So this example is something we saw in week 7 during the subqueries lab session. Part B was to use this table right here for this requirement. Is the table, the sales person table, and we are basically looking at how many salesperson have year-to-date sales greater than the average year-to-date sales. What is the average? We don't know. We have to compute the average. What is the average year-to-date sales? We have to sum up all the 17 year-to-date sales and divide by 17. And this is the investigation. So it's just simply the average on the sales year-to-date column. This is it. So this is the subquery approach, where you take that value, put in the subquery. That's a query, inner query, or the child query. It's going to return this value, which will then be passed to the outer query. So we are counting the number of salesperson from this table whose sales year-to-date value is greater than the average. And what's the average is what is investigated right here. Right. So this is the subquery approach. In a variable approach, you can actually assign this value right here into a variable. So see what we're going to do. We are declaring a variable called average sales year to date. What value would this variable hold? This variable will hold the value, this calculation right here. Right. So why setting the value to a variable? You can actually use a select statement to fetch that information. Above, we're just using any arbitrary value. Set this to this. Right. But you can actually fetch it from a query, and this is how you do it. You always have to use this and this, put it in a query. So not this one. So we are setting the variable average sales year to date. We are setting it to this, to the result of this query, and when you execute that query, we get this. So this is basically the value. So basically what we're doing is this, but this is static, right? What if the average year-to-date sales keeps changing? This will remain the same. But if you use the query to fetch it, it will run this against the database table, get the correct and the value, and then assign it to this variable. So this variable is going to hold this value, right? Is it going to hold it forever? We can then call it when we need it, and exactly we need it in this scenario. We want to count the number of salesperson whose sales year to date is greater than the average sales year to date. The average year sales to date was computed right here, and it was assigned to this value. So if you call this value, it will simply return the value it is holding. Each time you call a variable, the variable exposes the value it has in its keeping. Right. So this is it. Final solution to that. Sorry. Huge mistake. You cannot just execute the segment of this part without including the declaration of the variable. See, if I run just this part, right, the declaration of the variable is not included. The setting or assignment of the value to the variable, right, it's not also included. So the system does not know what you did right here. So it will always complain, must declare the variable that, see. So each time you omit the line where the variable is declared and the variable is initialized, you have always that error. So always include everything in the execution. So this is a total of 8 salesperson whose sales year to date is greater than the average sales year to date. And it's the same result we got from a subquery. Yeah, let's take another example. It will help to clarify. So all these questions, we solved them previously using a subquery, right? So write a query to retrieve the product information details for all products with weights above the average product weight. Some person will want to investigate the average product weight and then assign that value to a variable. Let me first of all expose you to the subquery approach so that we understand where we're coming from on this. This is a subquery approach where we actually investigate the average product weight. This is the value. And then we then return the details of products where the weight is greater than the average product weight. So this is the final solution. This is the subquery approach. All these 97 products have their weights above average product weight. Right, you see, option 2, using a variable, easy. Declare a variable which will hold the average product weight. Right, and this is going to be float or that's decimal. And then we set that average product weight equal to what value? This value returned by this query. This is where we investigate the average product weight, just like we did right here. Right, this is the investigation. Right, so this value right here will be set to this variable. This variable will hold this value. When we need this value in any calculation, we simply call this variable, right? And now we need it. We want to show all those products where the weight is above the average product weight. Average product weight is contained in this variable, and we know the value. This is the value right here, right? So when you execute everything, take note, you cannot execute just this part. It says you must declare, right? So you have to join the two segments and execute. See that? So that's the same result, 97 products with weights above average product weight. Subquery returns the same, 97 products with weights above average product weight. Questions? Okay, so let's check out this option. Remember we did this top rated businesses. This is on that interview website. So assume you're given the table below containing information on user reviews. I think we solve this together. Write a query to obtain the number of percentage of businesses that are top rated. So we're supposed to take the number of businesses that are top rated and divide by the total number of businesses. See, and they went further to throw more light on businesses that are considered top rated. For a top rated business, the review should be 4 or 5 stars. And that's why we incorporate that in the condition. So first, let me run this connection. And then next, I show you the full content of the reviews table. And then next, to get the percentage of top rated businesses, we have to take the number of top rated businesses. You see the condition right here. It meets exactly what was defined as a top rated business, 4 or 5 stars. So there are 9 top rated businesses. Divide by the total number of businesses. See, this one does not have any condition because we are going after the total number of businesses. So we are supposed to take 9 top rated businesses, divide by 12, and then we express that as a percentage. That's the goal of this question. So if you look at the subquery approach, and we're supposed to put this in a column. This is subquery showing up in a column, unlike the one above where we saw subqueries showing up in the where clause as a condition, not this one right here. Right. And now we know the 3 possible areas where we can place a subquery: on the select to define a column, on the where clause to define a condition, and also on the from clause from what we saw yesterday. That's a derived table. A subquery placed in the from clause of an outer query is a derived table. Right. So the reason why this count will give 9 is because of this condition. Right. This condition is also impacting anything we put on the denominator. So we want to isolate the denominator to run on a separate query. So you see what the denominator is returning, just the total number of businesses, no condition involved on this one, so that we hit our target 9. Right. So this is a subquery approach. See, this is going to a column. Right. We are taking this number, we multiply by that, right, to express as a percentage, right, and then we divide by this. See, the denominator runs as a subquery. So we end up getting 9 divided by 12. That's the percentage of top rated businesses. So we show the number of top rated businesses and then the percentage of the top rated businesses. See? All right. This is a subquery approach. In a variable approach, you can actually take this calculation right here and assign it to a variable. And then you just divide this by the variable. That's what we see in option 2. So first of all, let me conclude this segment so that we see the subquery version. All right, there were 9 businesses that are top rated. What is the percentage of top rated businesses? Is 9 divided by the overall, which is 12. So 75% of businesses are top rated. That's how you can express this as a percentage. All right. And last time we talked about a format function which expresses things in percentage. I can just copy all of this calculation, right? Control C, and I can use that format function, format. And remember, format, you put the value you want to format. This is the value you want to format. You put a comma, and then you put P, which will stand for percentage. And then you can, 2 is a default. If you put 1, you get 1 decimal place for the percentage. If you put 2, percentage in 2 decimal place. So 2 is a default. All right, let me just run this so that you see how. Right, you see right here. By multiplying it by 100, we've already expressed as a percentage, so that is, I have to delete this. Right, that's double expression of percentage. The reason why you multiply by 100 is to express as a percentage. So since I'm using the format function, I have to discard that part. Right, this goes to, this is messed up. And the reason now is data type. This is a very interesting thing going on. Remember, we had 9 divided by 12. If you just go to your query and put 9 divided by 12, see what happens. This is an integer, this is an integer. The outcome will be an integer. Run this, see, 0. That's similar, right, to what we're getting right here. But I'm just going to dismiss that one. And this one is better. It helps to, so if you do this now multiplied by, see this part right here, I'm just going to copy this. This count, including this condition, gives us 9. So take that 9 and express it in this format. So you now is basically transformed as a decimal. This is now a decimal in the numerator. This will now give us a decimal. As long as the decimal features in the numerator or denominator, it will transform into decimal. You see that the answer now is much better compared to this scenario where we just took strictly whole numbers, numerator and denominator, and we get a whole number. But if I step in there and transform this into 9.0, for example, decimals have power over integers, so it forces it to be a decimal. Now multiplying this by 100, you see, that's the role of this 0.0 right here. Because if I remove this, it doesn't create any impact. You see, it will still mess that up. You see, 75. But now including that decimal, that 0.0, see that transformation, see the final this thing we have. See that? So it's a data type issue. That's why we have this. I say, but why don't we just multiply by 100? We are adding this to just do that conversion from decimal, from integer to decimal. Right, so this is what we have. Let's go back to what we have. So this is the subquery approach. Right, the count total number of businesses is run on a separate subquery, so that this where clause does not intervene in that process. You see that? We want to get 12 in the denominator. If you include this where clause, you will have 9 divided by 9. See? So this is a subquery approach. You can easily solve this same question using a variable. Just go and assign this calculation right here to a variable. See, this calculation returns 12. Assign that 12 to a variable. And that's what we do in this approach. So let's start by declaring a variable. This is very important. This is the name of the variable, total business count. And it's going to be an integer. We now set that variable to hold this value. That's the 12, you see. If I execute this, I get 12. There are 12 businesses that we reviewed. Right. So this has been held in this variable. Right. So whenever you see this query, just put that variable. Right. In the subquery, we had it right here. So you see, that is taking the position of the variable. The variable is holding this information. So put the variable in that position so that when you execute this query, it will take the total number of businesses that are top rated, which is 9 multiplied by 100.5, divide by this variable. What is this variable holding? It is holding 12. Right? So each time you call a variable, the variable shows up with the value assigned to it. And that's why it's very important when you declare a variable, go ahead and assign a value to it. We use the set operator, set this to assign a value to the variable. And now this part alone cannot be executed. You must include the declaration of the variable and the assignment part of the variable to a value. Right, this is it. So I don't know if you're a fan of a subquery or a fan of a variable. I just wanted you to know both, right? So that we start seeing this symbol showing up. You understand? Right. And before we close on this chapter, I want you to understand this difference. Local versus global variables. So a local variable is the ones you and I define. And local variables will have the symbol, a single at. So all local variables are defined by the end user, right? And they are local to your laptop. If you define this variable on your laptop, I don't have access to it. See this variable I've defined. If you define it on your laptop, I have to do the same on my laptop in order for me to have access to it. So that's an example of a local variable. Right? And all local variables have this symbol in front of them. Right? This is very important. They all begin with this symbol, local variables. Now, global variables, on the other hand, so everything we've defined above, that's a local variable. Now, for global variables, on the other hand, they have two of the @ symbol. And usually these global variables are designed by Microsoft. For example, if I ask you what version of SQL Server are you using, there's a global variable which holds that information. So if I type version, this variable is holding an information. The version of SQL Server, that information is stored in this variable. So this is, see that this is a global variable. If I execute this, it will tell me what version of SQL Server I am running. I am running Microsoft SQL Server 2022, and it gives me this information. Right, Microsoft Corporation Developed Edition. This is, it was built. This is, see. Right. What is another one? What is your server name? Right. Let me give you another example of a global variable. So these are things that Microsoft has built and store information. Let's look at the what's your server name. Let's begin with the server name. See, this is a global variable. You can execute that. The server name is the information that pops up when you're trying to connect SQL Server. See, server name, desktop, da 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 da. You see, if I copy this information, it's the same. It's going to vary from individual to individual. See, so these are information. These are variables that are containing information. They are built by Microsoft. I have access to it. You also have access to it, so you can run them. But if I define a variable on my laptop, you cannot call it on your own end. Why? Because that's a local variable. It is local to my laptop. See, local to my server. But the global ones, as long as you have SQL Server Management Studio, I can run this variable, call it at your end, and run it. See, it's going to be available to you. It is available to you. It's available to me. It's available to everyone. That's why it's a global variable. Right, and the whole information, you see, that's the power of a variable. It holds information. When you call the variable, it releases the information it is holding. I want to know my server name. This is the information you run. That's your server name right there. Right. And that's the same information I copied on that login. See that? This is it. Right. There's another one. Server service name. So select. Just a moment. Select. So all these global variables, you just call them at your end. You see it is available for you. There's another one called service name. Just run this. See, the service name is the last part of this. So this part. Meanwhile, the server name gives you the two-part object name, the name of your laptop and the version of SQL Server you're running on. So this first part is the name of your laptop, and then forward slash, or sorry, backward slash. This is now the version of SQL Server you're running on. Right? Is it these names were provided during the installation? For example, if I go to the connect, we know how to get the server name as a global variable for server name. For the service name, I can now go to browse for more, go to the database engine, and all instances I've downloaded. I have IPing 2022. This, see, those are different instances of SQL Server I'm running on. But the one I'm currently connected to is this one. So this instance I'm connected to, and it's running on this server. That's my laptop. So that's how you can fetch the server name. You can use this to fetch the year. What language is your SQL Server running on? That's a global variable information. There are several of them. These are just few I can remember. You can just type as a language right here, execute US English. Right, these are all global variables. Right, so examples of global variables. These are them right here. Right, and you see what they all have in common. They begin with the double at symbol. Right, let me share this. Right, so all global variables begin with a double at symbol. Every other thing we've seen above, those are local variables. Right, so let me share this part. Please just copy this part and attach it towards the bottom so you can just be aware of the two types or two groups of variables. You have the local ones, which are defined by the user, they reside on your local server, and the global ones are built by Microsoft. They have this and they're accessible to everyone. You can just call them, run this, the information is there, run, see. Yeah, so those are global variables. Okay, any question? Okay, let's do one more example on this. So let's go to Global Superstore, and I want to show like stuff from. I think I did build something similar. I think that was yesterday. I want to show track some business metrics across different months of a particular year. And let me first of all do the different years. So let's do select this thing. Let's use the year function and simply extract the year from the order date. Right, so that we can see the different years that are available right here. See that? Right. And then in the next thing, now we can track let's also track the different months available. Select this thing, and for the month I want us to actually get the name of the month. So let's, in this case, really we're gonna need a date name function. Right, and we want to extract month, actual name of the month. This is the combination right here. See that? And if I want to order this process, right? If I want to order this process, I will need to do an order by right here. But this order by will now be tied to just the month, since the month will give us the calendar. If I order by 1, it is going to order by the date name. That's a string. It's going to give you April, August. This is the alphabetical order of the month names. But if you want to order them based on how they appear in the calendar, you have to use the month function, which is going to return an integer between 1 to 12. So 1 will mean January, 2 will mean February, in that order, you see. So that's in sorting. We talked about this last time. When you're sorting, use the month function to sort on. All right, so 1 January, 2 will be February, 3 March, just like that. So if I run this sort modified, this order by must appear in the select list. Yes, so it wants me to add this in the select list. All right, so yeah, you can do that. I can put this right here. So select distinct. I will be calling 2 of this, select distinct that. Then now you can run this. Yeah, and the sorting is nicely done. You see. So sorting on this one, which is the month function, it gives this arrangement 1, 2, 3, which follows this. See. All right. So what I want to do in this, I now want the actual stuff. I just want to track some business matrices across the different year and month. First of all, I will need this. In fact, let me just get this tool. And this is where we're going to begin, like here. And then the next one will be the summation. Let's get the total sales. All right, total sales. And this gets the total sales. I'm going to take this and switch it to another quantity. Let's switch this to profit so that we can get the total profit. So you understand where I'm heading with this one. We're going to be calculating this across the different years and months. This is going to be total profit. And what next can we get? Let's get the total quantity. Let's switch this to quantity so that we can get total quantity. Let me execute. So this is going to fail if I execute, because you see aggregated columns, these 3 are aggregated. These ones are not. So these ones have to go into the group by. Let me just go ahead and put alias to them as well. So this will be the order month. Order month. Let me get actually the name of the month. Name of the month. Yeah, this will be the order month. And then also I want to include the year. From a hierarchy perspective, I think the year should be better. Bring in the year. So I'm going to transform this into year. So if you notice, these 3 columns are aggregated. This, and this are all aggregated. Why these 2 are non-aggregated, right? So we have to add these two in the group by. Remember, we cannot put a column alias in a group by. So that's why I'm not going to copy this a column alias. I cannot put in a group by. So you cannot do group by this, column alias, comma, group by this. These are all column aliases. By the time the system is processing the group by clause, these aliases have not yet been created. They are created on the select. The select is processed after the group by. So you to refer to these columns, you have to go back to their logic, the calculation that was used to generate them, right? Because now this calculation involves a column which is already in the table, in this table, right? So the system will recognize that and this one as well, right? But when it comes to the order by, you can actually use those aliases. So this is what we have. So for each year, we have, this is a lot of data, 48. So for each of the, how many years we have? 16 years. For each of the 4 years we have, we also have 12 calendar months, right? So 12 times 4, so 12 by 4, that's just the amount of data we are projecting. That's 48. So this is giving us 48 rows of data. This one right here. 4 years across 12 months. Right, 48. And you can actually order. Let's begin. Let's order by year. Right, I want to order by year. So yes, you can take the alias and place it right here. It will approve it because by the time the system is processing the order by, the select clause had already been processed and this is now recognized. Right, and then within that, I want to order by what we did previously. I want to use the same logic, order by the month. Because if I order by, if I follow the sorting by month, the date name, it will give me the calendar order of the month. So I want to first of all sort on the years. Then now within each year, you sort on the month. You see, that's a double sort process. So you see, the first sorting is working. We are sorting on the year. We have all the 2012 data right here. 12 months for the 2012 data. 2011, sorry. Now we see the second sort is sorted on the date name function. That's why it's beginning with April, August. We don't want that. So this second sort has to be done on the month function, which will be 1, 2, 3, 4, right? Which will correspond to the order of the months in the calendar. So I'll switch that. Let me run this. Yeah, remember we had the same error above. We just simply have to add this into the select list. If you read the error, it wants you to add that into the select list. Column this is invalid in the order by because it is not contained aggregate or the group by clause. Oh, so yeah, we can add it in the group by actually. Yeah, in the group by, just make a space in the group by and add it right there. So our group by, let me just try to arrange this. Is this, and this. Now let's run this. Now you're doing a good job. If you look at the first sort was on the year, which is now nicely done. Our lowest year is 2011. So yes, we are beginning with 2011. These are the 12 months in 2011. And you see that the second sort is done on what? The month. And that's why you see this result is nicely achieved. This takes some little bit of patience and practice as well to get this right. So when you sort on the first one, it's not going to be enough. Right, the years will be listed in the order in which they occur true, but then within each year now, you have to do a further sort by the order in which the months occurred. See, right, so these are the 12 months in the year 2011. We can then follow through by the 12 months in the year 2012. follow through with the 12 months of the year 2013, and then finally the 12 months of the year 2014. Remember, this was a 4 by 11, 4 years, 11 months. And that's how we get the 48 total number of rows. Right. You can make out a stored procedure from this process where you're gonna call a particular year and you call a particular month and you see just the result. Right. Let me do that. So this is the query we have. Right. This is where I wanted to arrive. So using the query above, create a stored procedure with a month and year parameter. Right. So I will provide this query. So using the query above, this is now the question. Right. First part is going to be a stored procedure. Second part is going to be a variable. Right. So using the query above, right, create a stored procedure with the following two parameters. Right. In stored procedures, we call these parameters, but these are variables. Right. So using the query above, create a stored procedure with the following two parameters. So there will be a parameter for other month, and there will be another parameter for the other year. See that? Okay, so this is the first part. In the second part, let's just go ahead and solve this first part. So this is stored procedure. Right. So always stored procedure, it begins with what? The query. So this is a query. The only thing we need to add to this query is that declaration of it being a stored procedure. So first, we've tested this query, understand what it's doing. Right. Now I want to transform this into a stored procedure. That's just the create proc. Right. Just a moment, guys. Let me provide this query to you all so we can just run it together. This is just going to be revision for the stored procedure so that we highlight that concept of variables which are used in stored procedures and user-defined functions. Right. Variables were supposed to be treated before stored procedures. Right. So I want to create that connection. So this is create proc. Let's just call this month, year, sales analysis by month and year. Okay, yeah, it's better. Sales analysis by right. See, and since this third procedure will use two parameters, in the next line we'll proceed to define those two parameters. We have the first one is going to be the other month. Remember how we define parameters in stored procedures? It's a variable actually. So I'm going to put this, and usually you don't put spaces. Either you put an underscore to connect like this, or you just put fuse together. And since this is a parameter or a variable, it must have a data type. Right. So the other month, I want it to be a string. Right. Don't pass the name, the number of the month. So let's pass the actual name of the month. So I'm going to make this a string, data type string varchar. Let's just put 20 right here. So this is the first variable for that stored procedure, the first parameter. The word parameter or variable can be used interchangeably. This is actually a variable. This is a local variable. See, when you define a variable, you must put the data type. See, so this is a string. So we're going to be passing it to the date name part of the query. Now the second variable is the year, order year. So this initiates, that is a variable, is a parameter. Avoid using spaces in your stuff. Right, this is the order month. We're going to use the same for the year. Yes, integers is fine. So let's put an integer for this. See, right. So these are the two parameters or two variables which we've defined for this stored procedure. Right. And if you remember very well, when you define a stored procedure, what do? You have to use it in problem solving. Sorry, in filtering, in the where clause basically. And I'm missing something. There's an AS keyword. Create procedure. This as this follows. It's like a view. Create view. The name of the view as that. Right. And we need to use these two parameters or variables to filter the stored procedure. So we need to incorporate a where clause. Right. So since this does not involve aggregation, right, we just want to state where the name, actual name of the month is equal to whatever value you will pass in the stored procedure for the other month. That's a string, remember. That's why I'm tying it to the date name function, not the date function, right? Not the month function, sorry. The month function gives you an integer, but the date name function will give you a string. So that's why I'm tying it to this one, right? And then these are two mandatory stuff. The next one is the other year. So where are we getting the other year? This. I am not using the alias because aliases are not allowed in the where clause. This condition is going to the where clause. So that's the first one. And then the second one is this, the date name, sorry, the year, which is going to be an integer. The year pulled from the table should be equal to the year the stored procedure user will pass into when calling the stored procedure. So when executing this stored procedure, you must provide the month you want to see the sales analysis for, and also the year. These are two mandatory parameters you have to provide. All right. And then sometimes I want to show you something. You can actually initiate a stored procedure, the parameter of a stored procedure. What do I mean? You can actually say, hey, if you run the stored procedure, it should first of all run and show me the values for January. You see, this is a knowledge we've borrowed from a variable where you declare a variable and then you initialize it. If I go all the way to the top, I've shown you that you can create a variable and after the name of the variable, you put an equality, you initialize it right here. So in this case, we have this is going to be the default value of the variable. All right, so when the stored procedure runs, it will automatically first of all show you the where's that spot? It will automatically show you the year. Now this is the other month. I want to set it to, let's just go December, the very recent one, right? December, right? And then on this one, the other year, the very recent one, it was 2014, right? So give me the recent month and year when you run this stored procedure. So this is what we call the default values for the parameter. I've initiated them already. This knowledge right here is borrowed from the knowledge of variables. The only thing we are missing right here is a keyword declare. When you're building a stored procedure and you're identifying or declaring the variables, you don't need to put that keyword declare. You just state it, and then this is initialization. Let me just confirm those values. Okay, guys. So sorry about that. This is what I want to do right here. So I want to check the values. I want to check the values for the year, and just to see that 2014 is the most recent right here. So we're going to default the year parameter to the value 2014. And then for the months, of course, December is the most recent, right? So yeah, so now we all set. I will just copy this and share with you all. Yeah, please go ahead and execute that store procedure. Let me provide this value, this query. Go ahead and execute that stored procedure and then test it by calling it. Let's run this. So this is going to run on Global Superstore. I forgot to mention so switch to Global Superstore before you execute that. So the query has run successfully. We've built this stored procedure called this. You can go to Global Superstore and check it. All right, so this is what I want you guys to do. All right, we're going to take a break. All right, I want you to.
Mr. Blaze, do you mind sharing the script in the chat, please?
Yes, I just did. Check this. Check the.
Okay, thanks.
Yeah. So just go ahead, connect to Global Superstore, execute the script, and then proceed to test. See, now this one has the default. Remember, each stored procedure you execute, which has a parameter. You can go ahead and test this. It will not require a parameter value to be specified. Why? Because it just defaults to the value we set in the default. See, we set the year to be 2014. This is just a special case. I want you to see this. If we did not set this year's its default values, it will prompt you to specify a value. So it defaulted to December. Why? Because that's the default value we use for the other month. So by default, it loads and just gives you this particular month and this particular year. Right? If you want to get any other combination, you have to state it yourself. Right? So I want to copy this again and execute it, stating a different combination. In this case, so I want you guys to choose different combinations of years and months and you execute. Right. Okay, let's take a 20 minutes break. And then we're going to come back after the break. I want you guys to play around with this. And let's come back after the break and continue. Okay, guys, are we back?
Yes, I'm back.
Okay, so I want us to do a quick check. We did execute a stored procedure against the global superstore database. And the name of the stored procedure is right here, sales analysis by month, year. So let's do it. I'm going to refresh this and we just do a check. Database folder. I want to target global superstore. Stored procedures, remember, they're on the programmability folder right here. Right here, stored procedure, and you can find it. Just this is the first stored procedure we're creating in this database. And if you want to check out the script that was used, you know what to do. You can always script out, put it on a new query window, right? Okay, so we did create this stored procedure and initialize the value for the two parameters. So these are what we call default values for the parameter. So when the stored procedure runs, even without you specifying any value for the two parameters, it will use the default value. So it loads with the sales data for 2014 December, you see. And if you want to do a change on this, for example, I want to check a different month for that same year. You remember the first parameter or the first variable is the month, right? So see what happens if I put, for example, I want to check out January. I instead put 1 and I go for the same 2014. I don't know if anyone has tried this. So remember our month variable was defined to be a string, right? And we are actually using, if you look at the filtering effect right here, we are looking at the actual name of the month equal to the name of the month you're going to pass in. But then if you look at what I'm doing right here, I'm passing in an integer, not the, so let's run this and see what happens. Nothing gets returned, you see that? Right, so this should instead be January, should be a string. That's how that variable was built to accommodate a string, right? And even the column which is tested in the query to filter what is passed in the variable is set to what? A string, the actual name of the month. So the actual name of the month should be equal to whatever value you pass in the variable. So I'm passing January for this scenario, and I'm keeping the year to be same as the default. All right. So what if what happens? Let me just run this. Let's do before we do the what ifs. What if I don't specify the parameter value for the year? All right. Let's see if the system is going to complain. Remember, the default is put in place, so it defaults toward 2014. All right. So if now change this, I want this for 2011. 2011, it did a year on that list we investigated. So you can see the builder of this process. I want to know the valid dates that are available. So the valid years, I did this thing. Right, it ranges from 2011 to 2014. Right. So without that, if I don't have that information in mind, I can. What if I want to check out January of 2024? Right. And if I execute this, we don't have any data for 2024, January of that year. See that? Let's try out September of the year 2013, and that's available. This is it. So you can see the outcome right there. Let's use this as a revision. Let's format the Let's update the stored procedure and format the total sales and total profit into dollar amounts, while total quantity should be formatted to a number. Right. So update the stored procedure above with the following adjustments. Right. So let's target total sales, format total sales as, so format total sales and total profit as dollar amount. And this is the first one. This is 2 GP, 2 decimal place. We're gonna do the same. The second one will just be the quantity sold. Total quantity sold should be formatted. Quantity sold should be formatted as a number. That's just a number. Quantity sold. So format total quantity sold as a number. So remember, it's just to take the same query, right, and transform the create to an author. Right. Remember how we talked about this. So copy that same query and then simply change the create into an author, and then proceed to do the changes. Right. And the change, this right here has to be formatted. So you can cut this off and just wrap the format function around that expression. The logic is this: we want to format this as a dollar amount. So that's currency, 2 decimal place. And we're going to do the same to the profit. These are all dollar amounts. Profit is a monetary outcomes. Profit will also be formatted as currency, 2 decimal place, and I'll make sure the parenthesis right here. This is going to be formatted as a number. Format this as a number to, that's N for number. This is number, 2 decimal place. So we've seen 3 versions of this: currency, number, and percentage, and all go with the format function. Right. Let me just run the inner part, this right here. Oops, it's not going to be possible because of the parameters right here. Anyway, yeah. So that's the update. Once you execute this, let me just share this. Let me first of all execute. Yeah, everything works fine. I am going to share this. All right, so you can just run that query. That's an update. That's an author statement. We are modifying the stored procedure we just created. Right. So that's how that is done. And if we go back and just execute without any values to the stored procedure, the defaults will be activated, which is December of 2014. And now the total sales value is formatted as a dollar amount, 2 decimal place. Total profit also formatted as a dollar amount, 2 decimal place. Total quantity is formatted as a number. You see, and you have that 1,000 separator right there. It's easy to read this. This is 7,000, you see, because of the 1,000 separator right there. Okay. Any questions so far? So yeah, go ahead and update that start procedure. Run the alter statement, and then go ahead and just execute this by testing the default. Right, and this is what you get. So all of this was done from a stored procedure perspective. Right, we can target the next part of this, which is now the variable aspect. Right, remember in this part A was the stored procedure segment. Right, creating a stored procedure from the above query. Right, so in B, you're gonna make use of variables. It is pretty much same kind of stuff. So in this B, I will use a variable approach to this. So remember, in a variable approach, you have to actually declare the variables. If I just go and copy the query, let me just copy. I will need just this part in the moving below. Right, you have to define the variable and assign the value, and then proceed to use the variable in the question. Right, so this part right here will need a declare statement. Right, and if you want to declare two variables, you just need to put one declaration. Right, and after declaring them, you simply state. So this is the first declaration. We want to declare the month, other month is going to be a string, and then we default it to, this is the equivalent of doing set this equal to this. We just fuse it to one, and then the set, put a comma, put the next one. Right, we don't need this. We needed that for the stored procedure. Right, now this is us actually using, it says a variable this has already been declared. I can just make sure I indicate that, hey, this is a different batch. See that comment go, that underline goes away. It's trying to connect this batch to what we did above, right? But variables are limited to, they are batch specific. I think I forgot to mention that. Let me just talk about this briefly. A variable cannot be created in one batch and then you're trying to call it on another batch. It's not going to be possible. Let me talk about that briefly before we proceed. So this is a standard way to do, right? All of this is in one batch, right? As long as you don't see the go keyword between lines, it means that everything you've typed is in one batch. So all of this will be submitted and processed together. Now let me show you another way to look at this. See, let me dismiss this. See that? And then I step in between this and this. I put a go. Right, you see, immediately I get an error. Right, because the system understands that these two lines are in one batch, meanwhile this is in a separate batch. So you cannot declare a variable in one batch and then you put a go in between. This is a batch terminator. Each time you see this, it separates whatever is above it into a different batch and whatever is below it into a different batch. So if I run this query now, it fails. Although I've highlighted all of them, right? So variables are batch specific. You must build and call them in the same batch. It doesn't matter if you spread them out, right? As long as there's no go in between, they are considered to all be in the same batch. Right? This is very, very important. If you put a go anywhere you've messed up that declaration, right? So they have to be submitted together. The goal is what separates statements into different batches. This is very, very important. So all your declaration, setting the variable into a given value and then calling the variable, they all have to be placed in the same batch. And what defines a batch is the presence of the goal. What separates things into different batches is the presence of the goal. I remember there was a popular example I did use to demonstrate this concept of batch. If I just call the function getDate, which will put today's date, if I execute this, I get this. Right. If I call this across multiple times, you see, these are 3 instances. I run them together, I will get identical results because they were all executed at the same time. See, this is identical to this, identical to this. They were all executed at the same time. See, now if I step in, I split them into different batch. This first line is on a separate batch. These 2 are in the same batch. If I join them again and execute, the first one will give a completely different result from the last 2. The last 2 will be identical because they're in the same batch. You see, this and these are identical. They're in the same batch. You may say, but what's going on? We all executed them together at the same time. Yes, but the idea of a batch in SQL is very important. It tells the system here, this should be executed first. When you're done with this, then move to this. That gap or that couple of seconds it takes the system to switch from this when it's done and get to this is recorded right here. You see, we look at this milliseconds part. There's a couple of milliseconds that has gone by for the system to process this and then move to this and process it. Right? You can see it becomes more interesting when you spread them across different batches. This one runs on a different batch compared to this, and the order will be respected. So it will get this, followed by this, then followed by this. So all these 3 will now get different values. See, they were all executed on the same date and time. But on the timestamp, you can see that the milliseconds is different. Right? And now back to where we started. This is where we started executing all 3 in the same batch. No goal is there to separate, execute. We are back to having them identical. See that? So this is very important. So variables are batch specific. A variable must be called and executed in the same batch. Right? So that's a very important thing I want to talk about in that. So for the variable approach to this question, now you understand this declaration is necessary. In a stored procedure, it's not necessary. Once you just tell the system, hey, I want to create a stored procedure, it already knows, okay, we need variables. And you just go ahead and put the variables. But in a declaration environment without a stored procedure or a function, you need to declare. These are the 2 variables, and I've initialized them with their default values. And now this is me using it, see, in a SQL statement. I'm using them right here. So it's the same way we use it in the stored procedure. We use it right here. See? And now I can bundle this. This is not a stored procedure where you have to do exec. Right? This is just a SQL statement which happens to use variables. And I can run it. Guess what? It will default to the values you specified. This and this. Now, if I want to change anything, I go back to this and do the change right here. I want to get the sales analysis for June of the year 2013. That's where I just need to go change it. It has nothing to do with this. It will link it up, see, and everything will work out nicely. As you see, and you just go back and run the declaration. So when it comes to processes like this, most people prefer the stored procedure, right? Because you're just running one line. After you've built all of that, you just stay right here and you keep running. You do the change, you run just like that. But in this variable environment, guess what? The change is done right here and right here, but then you have to highlight everything again each time you do a change and execute. Right. So I wanted you to see this process. Right. Let me just document this. So this one was using the query above, create a stored procedure with the following two parameters. This version now is the variable. In this approach, we have to declare two variables. I declare two variables, this and this, and use it in the query above. Right. So let me adjust the requirement for this. So in this one, we have to declare the two variables, this and this. So using the query above, uh, okay, so I've transformed this into this requirement. Right? And that's why we started off by declaring the variables. And for the other month, I'm just going to put this, use, let's say use June as default, use this as the default value. Right, so this is documented. You now understand why we did that. And then for this other year, we're going to do the same, use 20. Let me switch it to what we had previously. Previously, we had December, so use December for the other month. Right, so this goes back to December. Same thing we did for the stored procedure. And then for the other year, let's use the latest year was 2014 for the other year as the default, 2014, right here. This is an integer, so this string environment is really not necessary. We can dismiss this. That's an integer, right? There is fine. This is a string text, so it needs that string environment, right? And every time you need to run this, this part has to be included. If you just go to the select and run this, you're wasting your time. See, this is a variable, the declaration part, it runs, but it's not stored. Right? That's always the temptation. Students run the declaration part. It runs definitely. And then now they proceed to run the part which uses the variable that was declared above. So they do it separately. It cannot work like this. See? And also remember, you have to execute both of them together. If you include a batch terminator right there, you've destroyed that process. The declaration and the actual usage of the variable are on different batches. Even if you combine them together and execute, you've destroyed that process because a variable has to be declared, initialized, and called or utilized in the same batch. So I have to dismiss this. See, now if I execute this, the system understands. See, this is very important. Let me share this with you. So in this second, this is B. This is a variable aspect of it. I will update these notes. I'm going to send them to everyone. Okay, so any question on this? So you see, within a stored procedure, the idea of declaring the variable is not needed. See, this declaration part right here is not needed. Just initiate the process of creating the stored procedure, create proc, the name of the stored procedure. If the stored procedure runs on parameters, just go ahead and state the parameter, the data type, and then if you want to initiate it to a default value, set it right there. This is initiated to be an integer. We don't need this, right? But then if you're using the context of a variable, all the variables we use in the replacement of a start of the subquery, we had to declare them. We had to use this right in this position. So in this case, you have to start by declaring the variable, stating the data type, and then initializing it, setting it to a value, right? And the value is pulled from a query. This is a query right here. Now we can further investigate. Give me those products where the weight is above the average product weight. The variable is holding the average product weight value. So when we call the variable right here, it will release the value it is holding. And remember, we have two types of variables, the local variables and the global variables. The local variables, they have the single @ symbol. They're created by you and I, the user. The global ones, they have double @ symbol. They are created by Microsoft. They are available for everyone. So you can call this at your end. It will deliver with that value stored in it. Call this same thing, you see. Those are global variables. Right. Okay. I think that's good enough for variables. Key points of usage for variables. Stored procedures. We've seen an example of a stored procedure. Right. And user-defined functions, which you're going to see in the lab or during the projects. I will figure out how we're going to study that. Now, okay. Think we should be set for variables. Next interesting thing which is going to make us relax a little bit is the union or intersect. Easy way to just combine. This is similar to what joins are doing, but not really. Right? I always want to give enough gap between this concept and join so that students don't get confused. Right. So we're going to head to that direction. Right. I'm going to close this and we'll update you with that query, that script. Okay, the next thing we're going to open is the lecture for set operators. I think we have to begin by executing the database, this database right here. Go ahead and open the set operators database. Let's execute that before we target this set operators lecture, which is this file. So this is going to create a set operators database. Just run the script and we should be good. That was good. Fast. Yeah. So just execute the script, shut it down. You should have a new table, a new database called set operators with a series of tables inside. Let me just check that, make sure a set operators database was created. This is it. If you check out the tables, there should be a couple of tables inside. We have the customer and the employee table. Yeah, we're going to see more of that. And now we should be ready to open the set operators script, this one right here. This was the database script. This is the one with the actual lecture materials. Just open that. And when we talk about set operators, we have is borrowed from that set concept. Sets, when it's same thing like joins. We use Venn diagrams to demonstrate joins. We are also going to be using Venn diagrams to demonstrate set operators. But then in this case, it's going to be a vertical process. I want you all to understand this is the equivalence of stacking. So in a join process, we put like this. This is what? Side by side, horizontal. Right. This is for joins. For set operators, right, this is stacking. So you're putting one on top of the other. If you have this table, stack it to a table directly below it. That is union. This is the process of stacking. And this is what is a vertical alignment. You take one table. Usually I prefer this symbol because set will give you a understanding of joins. Take the result of one select statement, A, and set it on top of the result of another select statement, B. And the connection will be through a union or intersect, except this, all of these have different things they're doing. Right. Let me just demonstrate one of these concepts. Let's just erase all of these drawings. Let's okay, I'm going to take you to this. Let me use what do we have right here? Let me check inventory. Okay, we have inventory. We have customers on a separate table. I want you to just stay with me on this. We have customers on a separate table. Give me the name of the customer. Right. And I'm going to do the same on the other table, salesman. Right. So on the salesman side, dvo dot salesman. Let me run both of them. You see they show up on different results window. Right. So each query, when it gets executed, generates an output window. This one also generates another output window. See? Now, if I run both of them, I get two output windows because they are two separate select statements. Right. Now, I need to track what is common in the two. We have the name of the customer and the name of the city, the name of the salesman and the name of the city. Those are the only two things I'm going to extract. So on the customer side, that column is called course name, then followed by city. One. Second, on the salesman side, that column is simply called name, and the city is the same city. If I run it again, see, I want to demonstrate the concept of stacking. Take the customer information and stack it directly on top of the salesman information. See? So this column called customer name should be stacked directly on the customer name on the name column for this. See, this should be stacked directly on this. City also should be stacked directly. You see? Right. So we end up having those two scenarios. Right. So we are preserving the number of columns. Right. And we're going to see something very interesting. For stacking, which is what set operators, the number of columns in the first query should be equal to the number of columns in the second query. This is so that we have proper alignment. This is stacking. You want to take one crate of beer and put it on top of another crate of beer. That's stacking. Right? There must be proper alignment. So the same sizes should be stacked on the same size. See? And for tables, we can use the number of columns to see the size of a table. So since this is returning two columns, 1, 2, we can stack it on this one, which is also returning two columns, 1, 2. That's a very necessary and important condition for stacking. Right, and the next thing I'm going to do, let me just clear this so that we can proceed, is bring in the appropriate operator for the stacking, either union, or intersect or except. And we're going to go over one after the other so that we can understand what each of them is doing. So this, we understand that execution of this generates two different outputs, two separate select statements. This is very important, right? Two separate queries. And what do we expect? Two separate results, two separate outcomes, two separate queries, right? Two separate output windows, two separate output windows, right? Two separate output windows. Remember, when you execute a query, the system puts together what you requested in an output window. Right, so since we executed two queries, we get two output windows, this and this. Right. Now let me follow through with this. This one is going to be an improvement. I'm going to step in and introduce a union right here. And what do we see? We still have our two separate queries, but this time around we're going to get one output window. See? And that's where you feel the power of stacking. Execute. The two columns have been stacked on each other. And now I don't even know which is which. See that? This is very, very important. This is one of the best ways to introduce this concept. Right? And this foundation right here is very important. Let me share this and I pause the video so that you can have a moment to see this. This is something different we're going to see. You see, we've still been able to combine the rows from those two tables, but not through a join, through some very different process. And I want to pause right here so that you guys can try and just go over this, and then we're going to discuss. But I want to stop right here and give you some time to evaluate this. Right. Oh, check out the chat window for the queries I've just shared. Just copy, put on a new query window, and then execute and see if you can make sense of what is going on, and we can discuss further. Okay, any question on this? Yeah, I really wanted to pause so that you can explore this and see. So this stacking process was done right here. Right. And with this, we can now head on back to this and discuss this further. Right. There's uh, there's something right here. These articles. Yeah. I'll encourage you guys to check out these articles. Let me just put them right here. You're gonna need those to better understand it. So in this article, we've already set the foundation for the process we're going to go through. We have access to the employee table, we have access to the customer table, right? And those is made possible from this database we executed at the very beginning. So if I run this part to connect to the set operators, right, this article talks about there are two tables in our database, employee and customer. Yes, we can execute those. Right. In fact, this line is valid. I can just copy this and put it right here. It's simply being pulled from that article. Now this sets the foundation for this. So this is the employee table outcome, right? And then this is the customer outcome. If you're asked to generate a list that will contain employees and customers, if you do a join between two tables, what do you get? If one table has 1, 2, 3, 4 columns, the other table has 1, 2, 3, 4 columns, you will have a combination of 8 columns if you join the two tables. I just want you to combine the employees and the customers in the same outcome and just focus on their name and age. Just give me their first name, last name, and age. So I usually attract a column that is common to both. See, give me the first name, last name, and the age of both employees and customers. One list that will give me these three information. If you do a join, you will get a column for the first names of the employees. You also get a column for the first name of the customers, separate. You also get a different column for the last name of the employees. You also get a different column for the first last name of the customers. See? So for each of these 1, 2, 3 columns, you have 6 versions of them. 3 from the employee table and 3 from the customer table. But you see that with the concept of union, you can put together that information within just 3 columns. All first names of employees will go into all first names of both employees and customers will go into that column, which will be stacked onto this one. So it's going to have one column. So stacking is a vertical process. Imagine this is placed on top of this. They constitute now one column, and this will be the values all the way to this. You see? Second column, we have last name. We have one last name which will host the last names of the employees and also the last names of the customers. We also have one age column which will host the age of the employees and also the age of the customers. So these are the 3 columns we will show in the result, which will contain information across employee and customer. When you're crazy about joins, you try to implement a join between these two tables. You will have 4 columns from employee plus 4 columns from customer. A join between these two will give you 8 columns in total. But they want a 3 column scenario. This is a stacking process, not a join process. This is very, very important. So when you're analyzing data, you have to try to visualize the outcome. Am I stacking or am I joining? Join is a side-by-side process. You take the 4 columns of the employee table, you put it next to the 4 columns of the customers table. Together, they constitute a table with 8 columns. But in stacking, you first of all define the number of columns you want to get. I want to get 3 columns, first name, last name, and age. The stacking, this one will be stacked onto this one will be stacked to this one will stack to this. So you maintain the number of columns. So for joins, the number of columns is increased. Right. For union, what grows is the number of rows. The columns have been defined, they stay the same. And what extends these rows will be added onto this in the same one column. These rows will be added onto this in the same one column, you see, and just like that, see. So this is very important. Always visualize how the final outcome will look like in order to make a choice between a join or a union. That is stacking process. So retrieve the first name, last name, and age of all customers and employees. This is basically that question. So we're gonna go the union route because it's gonna stack these three columns from the employee side onto these same three columns on the customer side. That's what we call a vertical process. Right, remember I drew this a while ago. Let me just get the pen. So if this is the customers, the three columns are right here. Give me the first name. I want to try and visualize this. It's always very important to see it. Give me the last name. Give me the age. This is what I'll get on the customer side. That's the customer side. Let me get a different color. Now, if I move this information now, see, I want to make sure that the number of columns is the same. That's a very important condition for the union process set operators. Right. Now, on the customer side, we also going to have the same structure. There will be a first name column, so that the first names of these customers will be stacked onto the first names of these employees. Right. Same thing with the last name. The last name of the customers will be stacked on the last name of the employees. The age of the customers will be stacked onto the age of the employees. So you end up, you see, we are preserving the number of columns. It's going to be 3, and that's what this question wants. Retrieve this, and this. Right. For all customers and employees. So the data of customers and employees should be forced into these 3 columns. How can you do that? It's not going to go through a join, because if you join these 2 tables, you're going to get one column for first name employees, another column for first name customers. It will be separated. So stacking is the way forward for this kind of process. Right. Let me clear this so that we can go back to our editor and see this. So we need a total of 3 columns based on the question. These are the columns, this, and this. Joining employee and customer tables will result in what? 2 first name columns. So each of the columns will show 2 times. Why 2 first name columns? 1 first name from employee, 1 first name from customer. See, right? So you will not be able to. This is not the structure we want. Right. So I will gradually go to the union all and union difference. So all rows are returned, including the duplicates. That's the power of the union all. So all here simply means all, including duplicates. Is it possible to see an individual who is an employee and also a customer? If you go back to this article, you're going to see Charles Davis. This is a 21-year-old individual. The future on the employee table. Charles Davis, 21-year-old individual, future on the customer table. Of course, we are excluding the IDs because that's the point of differentiation. If we ignore the ID and focus only on first name, last name, and age, Charles Davis will show up twice in the combined outcome. Why? Because Charles Davis is both an employee and they also feature on the customer side. Right. So watch out when we run this and we put all. Union all simply means if there is an employee in this, is an individual in this, and also in this, this is very important. We have to dismiss the ID. Yeah, please go ahead and dismiss the ID. It will not. The ID makes it the 2 Charles Davis different. This one has an ID of 4. This one has an ID of 2. Of course, customer ID and employee ID are 2 different business quantities. Right, 2 different metrics. So if I run this while dismissing that ID, you see Charles Davis will show up. This is one version of Charles Davis and this is another version. So one of these version is coming from the customer table and the other one is coming from the employee table. The reason why we are seeing all the two versions is because we are doing union all. Remember the discussion right here is the union and the union all. So union all will simply combine the two tables or queries and keep the duplicates, including the duplicates. This is a simple interview question they always ask. Meanwhile, if you dismiss this, let me run this so that you see that now we have a list of customers and employees. See, if I remove this and put just union, Charles Davis will occur just one. This one is giving us 8 for the union all. Charles Davis has been kicked, one version has been kicked out, duplicates have been kicked out. He has 7. So what is the difference between union and union all? Popular interview question. Union all will return all rows including duplicate. This all is very important definition. It means duplicates will also be included if they exist or occur. Right. Meanwhile, the union is like this thing. It will delete or remove the duplicates. So Charles Davis will occur on one. Let me just address this. All queries combined using these, and these operators must have, this is at those conditions, an equal number of expressions. Expressions are also called columns from a tabular perspective in the target list. Right. So if I dismiss this, I've kind of failed on this because the query above has 2 columns. Meanwhile, the query below has 3 columns. Can you stack a 2-column query to a 3-column query? Execute. See, it fails. I'm just going to back out because of error. So you have to make sure that this is equal. This is a condition on the number of columns. This must be equal to this. And also the data type here should be similar to this. Also must correspond. Right. So union gives you what? Only the distinct rows are returned, no duplicates in a union. Right. So if you go back to the example, duplicate has 2 steps. It combines the data, stacks them, and then investigates if there are duplicates and remove the duplicates. So if you look at this one, Charles Davis is showing up only once. Remember, Charles Davis is both a customer and an employee. They show up on the customer table and they also show up on the employee table. So if we stack this and this, Charles Davis will show up twice. But if you want to dismiss the duplicates for Charles Davis, use a union instead of a union all. So that's why this is giving us what? This is giving us 8 rows. There are 5 for the employee and there are 3 for the customer. 5 plus 3, 8. But in that 8, one is showing up twice. Charles Davis is showing up one version right here, another version right here. This is possible because of union all. If you don't want to see a duplicate showing up, do a union simply. So union is like distinct, union distinct. So these are the distinct combinations of employee and customer, first name, last name, and age. Charles Davis is now showing up only once, and that number has been reduced to 7. See? So why union is a 2-step process, it combines or stacks the 2 into 1, and then investigates and kicks out the duplicate, second step. Why this is just 1 step, just combine the 2, and that's it. No extra step is done. And there's always a follow-up interview question. Which is faster, union or union all? Union is a 2-step process, so this is going to be faster. There are more steps to go after than this. So more steps to process compared to this one, which is just 1 step. Right. So this is definitely faster than this. So usually when you stack things, you lose the origin of the data. If I ask you, is Tom Miller a customer or an employee, right? It's going to be tricky. All right, so usually you can add something to differentiate, and this is the concept right here. So everybody coming from this is an employee. So you see, I'm introducing a new column which will have a value called employee. That's a category column. Let me run this so that you see. I'm listing all the columns ID. I'm going to alias it to identification. Anyway, before I even get to that, let me show you this. I want to keep it the way it was. So right here, we don't know which is which. I have employees and I have customers. They are now being combined together. I don't know if this Tom Miller is a customer or an employee, but I know that everybody coming from this is an employee. So what can I do? I can add a new column which will hold the value employee for everyone in this coming from this table. And I'm just going to call that new column category. Let me run this so that you see what happens. So you see the new column is category and it has employee as the value, and it is inserted onto everybody coming from this part. You see, those are employees. And I do the same for the customer side. I add a new stuff customer, and this is it. See that? Now, usually don't bother about the alias for the column on the second, because the first query defines the names of the columns. So since this one has category, this will go into this and it will be placed under a column called category. You see? So the first select statement in the union or defines the names of the columns. So if I now execute this through the category column, oh, something's wrong right here. So how many do I get? I have first name, last name, last name. Oops, sorry, I'm ordering by this. Let's order by first name. I dismiss the ID column. So let's run this. See that? So now I can tell you, okay, this Charles Davis as a customer. Right? This Charles Davis, another version, that's an employee. See? Although we are doing a union, right, we are still seeing the two versions because they differ at this point. If I dismiss this, then I've dismissed what makes the value, what differentiates the value. See, this will now go back to 7 because it's a union. It will dismiss one of the Charles Davis. You see? But as long as you bring in something that differentiates the two Charles Davis, one is a customer, one is an employee, although we are dealing with a union, all versions will show up. This row is not identical to this row. Duplicate means whatever you see on this row is identical to what is on this row. Category differentiates. Everything on this side is the same except this part. So that's not distinct. That's not duplicate. You see? So that's how you can, when you stack data coming from different tables, you can keep a tracker to just, track the origin of the different values in the combined outcome. This helps. So this is now the tracker which is helping us to know, okay, this is customer Milan Smith is a customer. This Lisa Williams, that's an employee, you see. Right. Yeah, and these other ones I'm just going to skip, and you guys can just go over and study this. Yeah, so I'm just going to skip these ones, and then this is an intersect. What is common? Intersect will simply mean what is in the customer table that is also present in the what is in the customer table which is also present in the employees table. That's basically what we see right here. And this has to be this use set operators. So the word intersect, tell me an individual who is in the employee table and is also in the customer table. Of course, we know that person is going to be Charles Davis. If as long as we are focusing on the first name, last name, and age, if you don't introduce ID, of course, it's going to pick up Charles Davis, because if you introduce ID, 3 is different from 2. That's a differentiation factor. But as long as you drop the ID and just check the first name, last name, and the age, Charles Davis is an employee who is also a customer. So intersect simply means give me a row that is present on this. See Charles Davis right here, and also present on this. You see Charles Davis right here. So when I execute these two combination, it will give me the Charles Davis one. Charles Davis is the only individual who is both an employee and also a customer. So that's how you investigate the intersect. This one. And then except is just straightforward also. Those who are in the first select statement, but not in the second one. So this is the intersect. That's just the intersection, what is common to the two select statements, except only rows present in the first. So the first one, only rows that are present in the first one, but not in the second one. So individuals who are strictly employees, they are employees, but they are not customers. Right? That is the meaning of except. So you see Charles Davis is not listed right here because Charles Davis is the only person who is in both. We are looking at those who are only in one side. And then if you flip it, you put customer above and employee below, you've changed the narrative. You're now looking at only individuals who are customers, but not employees. See, it changes the. So in the except, the table above drives the analysis. You're looking for those who are here, but not here. If you swap the table, you see now employees above, customer is below. So you're looking for those who are employees, but not customers. In the case of intersect, you can put it in any order, it doesn't matter. So the order of the select statement or table doesn't matter for an intersect, because this intersection, this is the same as this intersection, this. So it's going to be the same. But for the except, the one above drives the analysis. Right. I think we can end here for today. So that's it for set operators. I'm going to bring more examples during the lab session. And of course, we have one topic we have to cover before we get into the projects. This will be the user-defined functions. Okay, any question before we go? So I'm going to give you 1 hour back. I have a nice weekend and see you on Wednesday.
You too. Bye bye. Thank you.
Okay, man. Bye. Yeah.